Okay, hello my dear students of class 9 and 10. Are you fine? Assalamu alaikum to everybody. I think all of you are fine and you are enjoying fasting in Ramadan, and you are missing so many classes in Rajiv College. That's why I take some initiatives to continue your lessons. What lessons I did in the last class, you see, I discussed force, and force is related with mass and inertia. Then I described what is inertia. Then I also described the law related with these three: force, mass and inertia, which was described by Newton in his first law. And in the first law of Newton, he stated a body at rest or motion will remain at rest or in continuous uniform motion until an external force is applied on it. Today I am going to enjoy some other topics in this chapter, force. First of these, I will describe the examples, some examples of inertia. I will show you it in practical and you will understand it better. And what lesson we will go later, I will describe. So let us pause. So we are going to enjoy some lessons of physics of class 9, and what we are going to enjoy in our lessons today. You see, we already discussed mass and inertia and force, and I also described the effect of force to change inertia. Then in the last class we discussed Newton's first law to relate inertia and force. So today we will discuss different kinds of forces, and like push, pull, balanced, unbalanced, action, reaction, electric, magnetic, gravitational force, then also contact, non-contact force, nuclear force, mechanical, non-mechanical force, and others. And I also give you some homework, then I will also describe four fundamental forces in the nature. So now I am going to discuss pause the. So today I am going to describe some examples of inertia that I told you. Pause.
Opposite team falls backwards. This tendency to fall backwards despite letting go of the rope is due to inertia. That is, if an object is at rest, it tends to remain at rest, and if it is in motion, it tends to stay in motion. This property of an object is called its inertia. Inertia can be classified into three categories: inertia of rest, inertia of direction, inertia of motion. Certain experiences that we have while traveling in a bus can be explained on the basis of the law of inertia. When a passenger is standing in a stationary bus that suddenly moves, the movement pushes the passenger backward. Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that started moving, whereas the upper part of the body continues to be at rest because of the inertia of rest. Inertia of rest is the tendency of a body to resist any change in its state of rest. What happens when a fast-moving bus negotiates a right-hand curve on the road? The passengers will tilt to the left. Inertia of direction is the tendency of a body to oppose any change in the direction of its motion. With the application of sharp brakes, the bus stops all of a sudden and the passengers tend to fall forward. This is due to inertia of motion experienced by the upper part of the body. When the bus is moving, the whole body of the passenger is in a state of motion. A sudden halt caused by the lower part of the passenger's body that is in contact with the bus comes to rest. However, the upper portion of the body remains in the state of motion due to the inertia of motion, causing the passenger to fall forward when the bus stops suddenly. Inertia of motion is a tendency of a body to resist a change in its state of uniform motion. Thus, Newton's first law is also called the law of inertia. Well, now this law should make sense. Do you understand why a ball on the ground after being kicked does not keep moving forever? The ball stops after some time due to the unbalanced external force applied by the ground in the opposite direction. Things to remember. Newton's first law of motion states that a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. Two unequal oppositely exerted forces are called unbalanced forces. Newton's first law is also known as the law of inertia. The tendency of an object to continue its state of rest or of uniform motion in a straight line is called inertia. The three types of inertia are inertia of rest, inertia of motion, and inertia of direction.
Okay, my dear students, I think you understand the video clip. Now I am going to do it in practical. You see, I am having a glass and then a cupboard, and then on the cupboard weight and heavy coin-like device. So you see, all of these are at rest. All of these are at rest. So if I push the cupboard, if there is any inertia of this coin, then it will go inside the cup. Let us see. You see? Do you see? Do you enjoy the fact? You see the body inside the cupboard. Pause. Okay. Start. Okay, I do it again. You see, if I push it very slowly, then it doesn't move. It doesn't fall inside the cup. It moves with the cupboard. You see, so it is not going down. But if I push the cupboard very first, I jerk the board very first, then the coin moves inside the glass. Do you find it? So this is called inertia of rest. Pause. Now for inertia of rest, you see rolling round shaped body is rolling, and it will stop when there is a force acting on it. So it is not continuous in its motion. Okay. So I think all of you understand what is inertia of rest and inertia of motion. And next, what is our next lesson? Let us see another video clip and I will describe it. Okay. Now I am going to describe a new topic. Let us see what is in the topic. Yes, actually we are going to discuss different kinds of forces. First one is contact and non-contact force. Let us see what is contact and non-contact force.
What happens when forces are unbalanced?
Pause.
Welcome to Moo Moo Math.
Okay, first let us discuss what is in this video clip.
We use force to change the state of motion of different objects in order to perform our day-to-day activity. For example, we push or pull the door to open or close it. We exert force to move the book from the bookshelf. We exert force in order to cycle. We also exert force to hit the tennis ball. Now notice that in all these cases, that is when we were pushing or pulling the door or when we were hitting the tennis ball, we were actually coming in physical contact with the object on which we were exerting the force. Is it possible to open or close a door without actually physically touching it? Or is it possible to move a book from the bookshelf without physically touching it? Well, no. So, such forces in which physical contact is a must are known as contact forces. Can you give me another example of contact force? Well, we've studied that all surfaces exert a force on all objects placed on them, and this force is known as the frictional force. Now, and so frictional force is a contact force. Now, you would be surprised to know that not all forces are contact forces. That is, there are forces in which physical contact is not a. Now observe this video. We notice that when we bring the magnet near metallic objects like the battery, nails and the safety pins, the magnet attracts the objects towards itself. Now from Newton's first law of motion, we know that an object at rest would continue to be at rest unless an unbalanced force acts upon it. So in order to attract the metallic objects, the magnet must have exerted some force onto the object. This force exerted by the magnet is known as magnetic force. But notice that the magnet did not have to come in contact with the metallic objects to exert this force, and hence such forces are known as non-contact forces. Have you ever tried rubbing a comb against your hair and bringing it near some paper clips? You would observe that the paper clips get attracted to the comb. This is because of a force known as electrostatic force. Since the comb was not in contact with the paper clips, electrostatic force applied by the comb is a non-contact force. If we throw an object upwards, it eventually comes down. What pulls it down? The earth pulls it down. The earth exerts a force in the downward direction on all objects, and this force is known as the gravitational force. So gravitational force is also a non-contact force. So contact forces are those forces in which the object exerting the force needs to be in physical contact of the object on which the force is being exerted. And non-contact forces are those forces in which physical contact is not required.
Okay, I am going to discuss about another force, which is, let us see the video clip, then I'll describe in practical
What
too.
happens when forces are unbalanced? Welcome to Moo Math and Science and Balanced and Unbalanced Forces. Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. But how are balanced and unbalanced forces different? Balanced forces will cause no change in the speed of an object. Balanced forces acting on an object in opposite directions and in equal strength, as shown in the arrows below, do not cause a change in the speed of a moving object. Objects that are not moving will not start moving if acted on by balanced forces. Remember, forces have a magnitude and a direction. Unbalanced forces are not equal, and they cause the motion of an object to change. When two unbalanced forces are exerted in opposite directions, their combined force is equal to the difference between the two forces. The magnitude and direction of the net force affects the resulting motion. This combined force is exerted in the direction of the larger force. Let's take a look at some real-world examples. The forces acting on the red pool balls are balanced. The downward force of gravity is equal to the resistance force of the pool table. When the white ball strikes the red balls, the forces are now unbalanced and they move in the direction of the force. The forces are balanced on the weights. The downward force of gravity is equal to the resistance force of the yellow rack. The weights do not move. The weightlifter exerts an unbalanced force upward, and the weights move in that direction. The forces on the tennis balls are equal. They are not moving. When the tennis balls are struck by an unbalanced force, it causes them to move. The resistance force of the car is balanced with the downward force of gravity. The car jack exerts an unbalanced force on the car upward, and the car moves in that direction. The car is at rest, and all forces are balanced. When the car that is moving strikes the car at rest, then the forces now are unbalanced, and the car moves in the direction of this force. If you'd like to know more about unbalanced or imbalanced forces, this playlist will help.
Students, okay, my dear students, now I am going to show you some practical example of contact, non-contact forces and balanced and unbalanced forces. You see, I am lifting up a comb. I am lifting up a compass. These are the all contact forces, and also you see I lift up the board is also contact forces. Now in case of non-contact force, let us see an example of non-contact force. The coin that I show you few minutes back, it is now inside the glass. You see it is a magnet, another magnet attracting each other. That's why the coin is going up, and it is moving, but there is no direct contact between the magnet, between two magnets. So the coin is moving up and down without direct contact. So this is a non-contact force, you see. So when we find there is no direct physical contact between two bodies, then it is called non-contact force. Okay, and another one, again let us see, it is magnetic force. So magnetic force is non-contact force, and again I use a comb, and then again I hold it to some small papers. You see the papers is lifted up by the comb. Do you find the papers? So electrostatic force is also a non-contact force. You see the papers. You see the papers are lifting up by the comb. Okay, so there is a non-contact force between these two. This is electrostatic force.